Density, mass, and volume is what we're looking at in this video, split into 6 parts. So first, we're going to start off by looking at examples where the units are consistent. Then we're going to move on to looking at examples where the answer is in a different unit to what's given in the question. Then we're going to look at what catches people out when they need to convert density to a different unit. Then we're going to look at examples where two liquids are mixed together, so sort of more problem-solving questions. Then looking at questions where we need to work out the volume of a shape first. And then finally wrap up by looking at an exam question. So the exam question we're going to look at is this one here. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause, and I've got the example on the right, which is you do. Now, the formula we're going to use to find the density is mass over volume. So the mass here is 12.5 and the volume is 50 centimeters cubed. So on my calculator, we're just going to 12.5, divide that by 50, and we get an answer of 0.25. Now the units here are kg per centimeters cubed. So hopefully you've pressed pause and got the example on the right. So we have density is mass over volume. So to find the volume, we're just going to do mass divided by density. And that is going to be 20 divided by 5, which is 4. The units of volume are centimeters cubed. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. And now moving on. So this time, what's different is the answer is expected in grams per meters cubed. So although the volume's in meters cubed, that's fine. This isn't. So that's in kg, that's in grams. We need to convert one of them. So we'll convert this one. So that can be written as 4,000 grams. So now, as usual, we do density is mass over volume. And then we get a mass of 4,000 grams. We get a volume of 2. And that just becomes 2,000 grams per meter cubed. Now you could have also done this without the conversion and converted it at the end. So you could have done 4 divided by 2, which is given you 2 kg per meters cubed. And then you could have times that by 1,000 to then get you your 2,000 grams. So you could have also done it like that and then the conversion at the end. So it's up to you what approach you take. So here we've been asked to find the mass. So to find the mass, we have density times volume. So we have, and what's the mass in grams? So what we'll do is we'll take the usual approach this time. So we'll just do the density, which is 3 times 5. So that becomes 15 kg. Okay, that's important here because the density is given in kg, but the answer wants in grams. So we just times that by 1,000, and that gives you the grams. Now you could have also converted this here. So that would have just become 3,000 grams per meters cubed, and then just worked with that number from the start, or converted it at the end like I did there. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. Now, this is one bit that has confused people. So how do you convert 12 meters cubed to centimeters cubed? Now, what's worth bearing in mind is obviously 1 meter is 100 centimeters, which then means 1 meters cubed. So if you times it by 100 to go this way, you're timesing by 100 cubes to go this way. So there'll be 1, 2, 3, 4, 5, 6 zeros that way. So 12, you times that by 1, 2, 3, 4, 5, 6, and then you get your answer as 12, 1, 2, 3, 4, 5, 6 centimeters cubed. So that is how you go from 12 meters cubed to centimeters cubed. Now, what people do here is they come here and they're like, well, actually, this question's asking me to go from meters cubed to centimeters cubed. So surely to go from 12 kg per meters cubed to kg per centimeters cubed, all I need to do is times it by 1, 2, 3, 4, 5, 6. Now, that is not correct, okay? That is not what we're doing here. You do not times by a million, you divide by a million. Now, you might be confused thinking, why on earth do you divide? Because the unit of density is mass over volume. So 12 kg per meter cubed, I would recommend you write this as 12 kg per 1 meter cubed, okay? Writing them both is the exact same. Now do the conversion. So what do we need to convert? The mass is fine. So you can just copy that over. The 12 kg is fine, but the bottom bit is not fine. You're going to convert this to centimeters. So how do you do that? Times it by a million. So if I now times this by a million, I get 1, 2, 3, 4, 5, 6 centimeters cubed. So my answer then becomes 12 divided by 1, 2, 3, 4, 5, 6 zeros, and that gives me 0.000. So we'll hop in it that many times, and then that'll be 1, 2. So that's 1, 2, 3, 4, 5, 6 hops, grams per kilograms per centimeters cubed. So hopefully you can see what's actually happened there is rather than timesing by a million, which, like I said, is incorrect. We've actually had to divide. And the reason we've had to divide is because this is how you actually write it out. Okay? You write it out as a fraction. Then you convert what you need to convert as usual. And then you realize the final answer is actually that. So here's an example for us to look at. Now, we've already seen this. And like I said, I'd recommend you write this as a fraction. So that's 4 grams per meters cubed. Now, the grams part is fine. So we can just copy that over. That doesn't need conversion. For the bottom bit, that needs a bit of work. So to go from meters to that, you just times it by a million. So that'll be 1, 2, 3, 4, 5, 6. So you're now dividing 4 by that many zeros. So that just becomes 0.1, 2, 3, 4, 5. And then that's grams per centimeters cubed. And then looking at the next one underneath, so we have 6 kg per 1 centimeters cubed. Now, both of them need converting. So first we need to convert kg to grams. The way we do that is timesing by 1,000. So that's that bit done. Now, the next thing we need to look at is this bit here. How do you go from centimeters cubed to meters cubed? Now, to go from centimeters cubed to meters cubed, you divide. So if you divide this by a million, that will just become 0.1, 2, 3, 4, 5 meters cubed. Okay, so that's what you end up with there. And then if you just do 6,000, divide that by 0.0000001, you end up with 6 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And then the units are grams per meters cubed. Okay, so hopefully you've pressed pause and got the example on the right. And the way you should have approached this is by writing it as a fraction, because that makes life easier. Then ask yourself, does the mass need converting? No, it doesn't, because the answer's in grams. Do the meters cubed need converting? Yes, they do. We need to go to centimeters cubed, which is just times a million. And that is that. And then if you just tidy that up, if you do 7, divide that by a million. So that will just be 0.1, 2, 3, 4, 5, and then 7 grams per centimeters cubed. And then sort of looking down here, we have 9 kg. Converting that to grams. And converting that to meters cubed. And then finally, you'll just have your 9,000, divide that by 0.1, 2, 3, 4, 5, and then you get your final answer, which is 9 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros grams per meters cubed. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. And now moving on. So we have a block that has a mass of 600 grams and a volume of 3 centimeters cubed, and it wants the answer in kg per centimeters cubed. I can make my life a bit easier here. I can just immediately convert this to 0.6 kg. So density is mass over volume. So 0.6 divides that by 3. That gives me 0.2 kg per centimeters cubed. And now looking at the next one. So here we need to convert. Again, it's the same thing. So just convert that. So that can just become 2,000 grams because it wants the answer in grams. So density is mass over volume. And that can just become 2,000, divide that by 4, which is 500 grams per meters cubed. Now here's some practice questions. Press pause and have a go. The only time you need to really be careful is here we are converting both the volume and that. So here's your answers. So moving on, we're now looking at questions where we are mixing 2 liquids together. So we have 2 liquids that mix together to give us liquid C. And it's asking us to find the volume of liquid C. Now, to find the volume of liquid C, we need, the density. The density of volume C, of liquid C, we need the mass, we need the total mass that's being mixed together, and we need the total volume. Okay, so that would be the total volume of A and B. So if I write A here, and I say for A, we have a density of 2. We have a volume of 15, which means we have a density is mass over volume. So if I just did 2 times 15, I would get 30 meters cubed. That is your, not meters cubed, 30 kg is your volume mass. So that's that done. And on this side, if I do B, now with B, it says the density is 6 kg per meters cubed. It says the volume is 5 meters cubed, and so the mass is just going to be 6 times 5, which is 30 kg. So that's all that done. Now to get the density of C, because we mixed both A and B together, we're going to take the mass, which is the total mass. So we're going to add the two 30s together, because these two got mixed together. A and B got mixed together to give us C. And then for the volume, we're also going to add them together. So we're going to add the volume of A and the volume of B. And that is it. So that becomes 60 over 20, and that becomes 3. So 3 kg per meters cubed is your answer. So hopefully that made sense. All we've done there is we've mixed two liquids together, but to get the final answer for the density, you need to get the total mass and the total volume. So on the right, hopefully you've pressed pause and had a go at this. So two liquids have been mixed together to give us a new liquid, and they want the density of the mixture, which is fine. So it'll be the same approach. So the density of the mixture, let's just call it density of M mixture, is going to be the total mass, M total, over the volume total. What's the total volume that got mixed together, and what's the total mass that got mixed together? So for A, we have a density of 10 kg per meters cubed. We have a mass of 200 kg. Now density is mass over volume, so volume is mass over density, so that gives me a volume of 20 meters cubed. So I've calculated that. And the same thing on the right, density is given. The mass, we don't know what the mass is, we can calculate that because we have the volume. The volume is 20 meters cubed. So density is mass over volume, so it'll just be 5 times 20, which is 100 kg. So finally, the density of the mixture is the total volume, which is 20 plus 20. So that's because these two got mixed together, remember, if we mixed A and B together to get the mixture, divide that by the volume. Sorry, it's mass divided by the volume. And then we just end up with 30 divided by 4, which gives us 7.5 kg per meters cubed. That is our final answer. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. And now moving on. So sometimes you'll be given examples like this where you actually need to calculate the volume. So in this question, it wants the mass. So we know that density is mass over volume. In fact, if I should write that here, so we know the mass is density times volume. We have the density, which is 1.2 grams per centimeters cubed. That's given in the question. We don't have the volume, but we can calculate the volume of this shape because it will just be the cross section, which is 6 times 3 because it's a triangle, divide that by 2, and then we just times that by the length. So that just becomes times 12. So 6 times 3 is 18, divide that by 2 is 9, times that by 12, and we get a volume of 108 centimeters cubed. So there we go. So all we have to do here is actually calculate the volume, and if I just do 1.2 times 108, I would get my answer, which is the mass. So the mass then becomes 129.6 grams. Again, exact same thing here. So we've been given the mass, and it's asking for the density this time. So we know that density is mass over volume. So the mass is 14 kg, and the volume, we can calculate that. So this is a trapezoidal prism, and we have to use the formula for that to find its area. So that'll be a half A plus B times the height, and then times that by the length, which is 20. So quite a bit going on here. So that will be a half 3 plus 15, which is your 18, times that by 6, and then times that by 20. So that's your volume. And then you just do 14, divide that by that number, and we get a density of 0.01296 kilograms per centimeters cubed. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. And moving on, we're now looking at an exam question. Now feel free to press pause and have a go at this yourself. So we've got two liquids that have been mixed together in a certain ratio. It goes into a cylinder that's filled with liquid C. And we've been given some details about the cylinder. So we know that they're both mixed together in some sort of a cylinder, right? And it has a radius of 3 centimeters and it has a height of 25 centimeters. So we can work out the volume So the volume is going to be pi r squared times 25. So that will just be 9 times 25, which gives you 225 pi. We can leave it as pi for now, so it's easy to work with. So we have the total volume. We know the ratios. So we know that for A, we know what the density is. So the volume is just going to be 2 out of 15. So that's from where I'm getting that from is here. So in total, it has a ratio. These two both add up to 15. So 2 out of 15 times that by 225 pi. So 225 pi times 2 over 15 becomes 30 pi. So now I know the volume of A. And for B, the volume of B is just going to be 13 over 15 times 225 pi. So that's just what's left over, which is essentially going to be 195 pi. So now that I have the volumes, I just need to get the mass. So it says work out the mass of the liquid, the container, all together. So just as a reminder, density is mass over volume. So it's just going to need the density times volume, just find. So total, what is the mass of A and B is all we need now. So the mass here is going to be density, which is 1.02 times 195 pi. So times that by 1.02, and that gives me 624.862778. If I swap that off, and if I find the mass of this one, because both of them are mixed together, we just need the mass of both of them, and we get our answer. So 1.21 times 30 pi, that gives me, in fact, I'll just write that on the line below, 114.03981133. And if I add that to 624.862778, I get an answer to 3 significant figures as 739. That is my final answer. So I've just added this and this together because they're both mixed into the cylinder. So the mass of this plus the mass of this must be what the final mass is, and the unit here will be in, let me see, grams. Yep, forgot to write that in. Now, if you would like some more practice on this, I've got a full worksheet linked down in the comments below. And if you found this video useful, I've got loads of other content like this. Do check it out.